All right, in this video, we have this piecewise function over here, and we want to find where this function is going to be not differentiable. Okay, so in order to figure out where piecewise function is not differentiable, we've got to first look at the individual functions first. So my first function is a quadratic function where the domain is less than -2. This function is basically differentiable everywhere. Quadratic functions are differentiable everywhere, so no restrictions for that one. Next over here, I have a reciprocal function between -2 and +1. We know that a reciprocal function is not differentiable at the vertical asymptote. And we know for this function, we have a vertical asymptote at x equals to 0, which means that the function is not differentiable at, oh, I spelled that wrong. I missed the en, differentiable at x equals 0. So we found our first point where the function is not differentiable. And the third function is a square root function, which has a domain of greater than equal to 1. Since it's a square root of x, I know that the domain is x is greater than equal to 0 for this one. Since my domain here is greater than equal to 1, the function is going to be differentiable at every single point greater than or equal to 1. So now that we've found non-differentiable locations for each individual function, we want to start by seeing the continuity of the function. So I want to first test whether my function is continuous or not at x equals to -2, which is the link between the first two functions here. So let me test the left side and the right-sided limit for this. So lim x approaches -2 from the negative side, the left-hand function is the higher function, basically the less than 1 over here. So that's going to be f of x equals -1 over 3 times x is just -2 squared minus 2 over 3. I'll do this in my calculator. I get -2. Then I will test at the right-sided limit. So lim x approaches 2 from the positive side, that's right-side limit, f of x, just this second function here, 4 over -2. Oops, I missed the negative here. That's also -2. Since the left side and the right-sided limit are the same, this means that the function is continuous at x equals -2. Now, since the function is continuous at x equals to -2, it is possible that the function is also going to be differentiable at this point, but we have to do some further testing to find out. But before I do that, let me find the continuity of the function at x equals to 1. At x equals to 1, my left-sided limit, lim x approaches 1 from the negative side, f of x. So at x equals to 1 is the second and third function together. So the left-hand side is just 4 over x. So 4 over 1, which is 4. And for the right-hand side, f of x is this final function here, which is -2 root 1 minus 3 times 1 plus 9. That's -2 minus 3 plus 9, which is positive. The function is also continuous at x equals to 1. Now, if either of these were discontinuous, we would automatically state straight away that the function is not differentiable at whichever point is discontinuous. But since they're both continuous, now we have to test the slopes at these 2 points. So the next thing I want to do is I want to derive this piecewise function. I want to find my f prime of x. So let's start with deriving this function. The first one there is pretty simple. 2 times -1 is just -2 over 3 times, and then x, the new exponent is 1, and the constant's going to disappear. To derive 4 over x, I'll simplify it first to 4x to the -1, and then if I derive this, it's just -4x to the -2, which is basically -4 over x squared. Then the third function, again, I'll simplify the root. So I'll rewrite this third function as -2x to the power of half minus 3x plus 9. And now I'll derive this. So f prime x, -2 times half is just -1. Half minus 1 is -half. And then this is just -3, and that disappears. So this can just simplify to -1 over root x. Just move this to the bottom and change the half to a root, -3. This is for x is less than -2. This is between -2 and 1. And this is greater than or equal to 1. So now I've got to test the slopes for these functions. I'm going to start by testing my slope at x equals to -2. So let's test the left side first, which is the first function there. So lim x approaches -2 from the negative side, f prime x equals this first function here, which is -2 over 3 times -2, which is +4 over 3. And then let me test the right side. So lim x approaches 2 from the positive side, f prime x. That's the second function here, which is -4 divided by -2 squared, just -1. Now, since these two values are not the same, the function is not differentiable at x equals to -2. So now I found my second point here where it's not differentiable. Then I gotta test this point here, 1. So at x equals to 1, lim x approaches 1. Oh, again, I missed my negative over here. Keep forgetting to write the negative there. Lim x approaches 1 from the negative side. That's subbing in 1 into the first function. So that's -4 over 1 squared, which is just -4. Then lim x approaches 1 from the positive side, f prime x equals, just subbing it into this function over here, so -1 over root 1 minus 3, which is also -4, which means that the function is differentiable because the slopes are the same on both sides and it is continuous. Function is differentiable, keep spelling this wrong, at x equals to 1, which means that this piecewise function is not differentiable at x equals to 0 and x equals to -2. This point here and then the original one from the restriction in the original function. Made to the end of this video and you found this content helpful, please hit the like and subscribe button. Help me get to 1,000 subscribers. I'm almost there right now. This is video number 519 without making a single dollar. So please, please, please hit the like and subscribe. I'd really appreciate it. Thank you for watching.